Hi, I'm Gwen Rudie, one of the staff astronomers at Carnegie Observatories. I'm an observational astronomer studying galaxies, which mean I use telescopes to collect the light of distant galaxies to understand how galaxies like our Milky Way form and change over time. So, as an observational astronomer studying the distant universe, one of the things I'm most excited about is the design and construction of even larger telescopes than the ones we have today. I'm particularly excited about a project we're working on at Carnegie, the Giant Magellan Telescope. The picture behind me shows an artist's rendering of what the project might look like once built and trained on our beautiful night sky. Each one of those disks is a mirror 27 feet across, larger than one of our current Magellan telescopes. And together, these 7 mirrors would make up the most powerful telescope ever built. So why is that? Why do astronomers keep building bigger telescopes? Well, there are two main reasons: light collecting power and resolution. Resolution is our ability to discern the details of cosmic objects or to tell two objects in space apart when they're very near to each other. And the resolving power of a telescope is directly proportional to the diameter of its primary mirror. The GMT will have an 80-foot primary mirror when measured across its segments, which means that if it were built in Los Angeles, we'd be able to use it to see a dime in Las Vegas. So that sounds pretty neat, but I don't study coins. For me, this means I'll be able to use it to see the fine structures within distant galaxies to better understand the processes that occur within them. The other main feature of large telescopes is their light collecting power. You can imagine a mirror on a telescope kind of like a bucket in a rainstorm. The larger the bucket, the more rain you get. So for a telescope, the larger the mirror, the more light from distant sources we can funnel into our instruments to study faint objects. And that is really, really important to me. I study extremely distant galaxies because I'm interested in the young universe. When I travel to Chile to use our Magellan telescopes, I'm typically collecting light that was emitted by galaxies 10 billion years ago. You see, light travels at a specific speed, and so the farther away we look, the farther back in time we see. But as we look farther away, and so farther back in time, the galaxies I want to study get fainter and fainter because they're farther from us. And so I need a larger telescope to see them at all. So a really, really big telescope to me is like a time machine, enabling me to see back to the earliest days of galaxy birth in our universe. The Giant Magellan Telescope will have 100 times the collecting area of the Hubble Space Telescope. And so it will be sensitive enough to see a single candle on the moon. More important to me, it has a large enough mirror that I'll be able to use it to study all kinds of distant galaxies as far back in time as the universe will allow. Thanks for watching. I hope to see you sometime soon at an in-person event at Carnegie.